So hey, my name is Christopher Chedeau, also known as Veja on the internet, and today I'm going to talk about Excalidraw. So you may ask like, what is Excalidraw? And so let me show you. So you go to excalidraw.com, you press enter, and then like less than 1 second later, you end up with this. And now you can start typing stuff. So in this case, we had React, and we had Europe, we had React Europe, and then like, oh, maybe you want to have like some rectangles around, and probably want to link them with an arrow. And then because it's supposed to be in France, allez bleu, and then it's blue. So this is what Excalidraw is. It's a drawing tool, so you can like sketch out ideas and illustration and those kind of things. And so I started working on this project. So it was actually January 1st, and I was procrastinating on writing peer feedback at Facebook. And one thing I wanted to do is to draw an illustration for my blog. And I've been using this tool called Zwibbler, like the demo version, because it costs quite a lot of money. And unfortunately, like there's been a redesign and like it stopped working for me. And so I was like, oh, well, I've always wanted to actually like implement and see how to implement a drawing app. And so I started using Code Sandbox. I started like with 100 lines of code, like building a small prototype, and then I tweeted about it. And one thing that happened is that I didn't expect, like, oh, I got like 260 likes, and like a lot of people were like super excited about it. And so I was like, oh, this is interesting. And so I put it on GitHub, and almost instantly, like people started contributing. And so now, a few months later, we now have like more than 80 contributors, and not just like, oh, I tweaked like a few doc settings. Like a lot of like people spend a good amount of time and like build a lot of features for Excalidraw, which has been awesome. So in this talk, I'm going to first start talking about like some of the examples that people have been using Excalidraw for, and then go into the details of like what are the things you can use it, like what are the interesting like behind the scenes things that we've done with Excalidraw. So the first one is Hans built like an illustration for a blog post about probably like video games or something. And so this is great because like this is basically like what I intended the tool to be used for. And oh, like it's actually a real tool, and like people are using it for this use case. So like this is like super heartwarming to see that like it actually works in practice. Then the next one is pretty cool. It's from Daishi, a core contributor from Excalidraw, and he's actually explaining how the rotation feature works using Excalidraw. So it's very meta, but also like very cool. Then if you think about Excalidraw, like the thing I showed you, it's basically like you can draw like text, boxes, and arrows. And what is this actually useful for is to draw diagrams. And so P. Jaitley used it to explain like how blockchain works. And so if anything, I'm finally super happy to understand like how blockchain works after all of those years. So even if Excalidraw didn't work out, like this would have been like worth it. And finally, the very interesting use case and like very popular use case is to design and to mock UIs. And so in this case, Duan has been mocking like his new cool iOS app for like managing songs. And so this is one of the thing which is interesting is like if you give like those primitives to people, like they're going to use it to do like a lot of different things that you may or may not have thought about. And the next section are things like I didn't think about using Excalidraw. Like when I started thinking about Excalidraw, like I would never think about doing those kind of things. And so the next one is Colin, and he's actually used Excalidraw in order to draw slides, like a slide deck. So in this case, I unfortunately didn't use it. I used Keynote. But what it did was to exploit the fact that we have an infinite canvas, and you can like start scrolling around. And so he did like, oh, an illustration for like every single part of the blog post, and then he scrolls through like all of the slides using this. And so he said like, oh, the scene is now 1.1 meg, and because of all of the optimization that we've done, and I'm going to talk about some at the end, he's been able to get it working. And then we started like when we finished like building the first version of the live collaboration, we tweeted about it. Hey, come into the room, like, let's do something together. And the amazing thing is that people self-organized, and they decided to like draw a bunch of flags and to draw like a scene like with Martians and everything. And so it's been a very cool like social experiment as well as in technology. And so this is going through art. And Gregor actually built like a comic strip using Excalidraw, which is also like pretty cool. And so this is like a lot of like interesting ways people have been using Excalidraw. And yeah, I'm super excited that like people are able to use it. So now in this talk, I'm going to talk about some of like the more technical things. And so I'm going to go through 4 of them. So the hand-drawn effects, rethinking the virtual whiteboard, end-to-end encryption, and like the way we actually do the rendering. So one of the things you've probably noticed with Excalidraw so far is that all of the like the drawing looks like have a hand-drawn kind of effect. Like they look sketchy, they look rough. And the thing that's actually interesting about this is the fact that it's hand-drawn has a lot of psychological effect on like the people actually looking at the drawing. And now they excuse a lot of the small things that like are not perfect. So for example, like, if you were like to have like to draw like super sharp edges or like super like normal text, then anything that's like a bit misaligned or like the padding is not correct on this kind of thing, like people are going to notice, and they're going to like basically just see this and not the actual content. But now if you like put the hand-drawn effect, then people are just going to gloss over this and say like, oh, this is a sketch, this is fine, and they're actually going to look at the content. And so by just doing this small tweak, we've been able to change the product and the way it's actually being used. So now the question is, how does the hand-drawn effect work? So it all started with like, let's try to actually draw a line by hand. And this looks something like this. And you can see like the line is a little curved. And sometimes like people also like to draw like multiple times to like put some emphasis. And so now how do you reproduce this effect in code? So the first thing we need to do is to figure out like a point. How do you get like a rough point? So for this, let's say you want to display a point at like 1010. In practice, to get a rough point, we're going to take a random point within this circle. And now the interesting thing is, given the size of the circle, it gives like the roughness. So the bigger the size, like the more rough or sloppy it's going to look like. So now that we know how to like have a rough point, now we can use it to draw a rough line. And so for this, as you may expect, we want A and like we want to do a rough point for A and B. But if you just do that, then you're going to have a straight line between A and B, and it's not going to be super rough. And so the magic trick behind like rough and Excalidraw is that you actually take 2 other points, one at 50% and one at 75%, and you use rough points. So now you have 4 points to draw the line. And now you can use a Bezier curve between those 4 points. And that's the trick. And the magic of this is if you're doing it 2 times per line, then it gives this like hand-drawn kind of effect. And so it's very like simple to implement, but it actually works extremely well in practice. And so I told how to draw a line, but now you can like, if you want a rectangle, you draw 4 lines. If you want an arrow, you draw 1 line like this and like 2 lines like this. And it composes like very well. So now this is like 1 line with 1 roughness. But now if we increase the radius, as I mentioned before, then you can get like a more like sloppy line. And so now one of the big questions that comes in is, okay, so now we have a way to control like how rough or how sloppy the line is. But now how do you expose it to the user? And so this is where like usability comes into play. And so the basic way, like the most obvious way you can do it is like, you put a slider, or maybe you put a drop down with a bunch of options. And so one thing I found, especially in my work with Prettier, is like you want to give like as few options as possible for people, because otherwise like it overwhelms them with options. And so in this case, what we've done is we played around with a bunch of different configuration and like values, and found like just three that are actually the thing that you're using most of the time. and we gave them like a real world name. So architect, artist, and cartoonist. And there's no drop down. You can start and you can click on architect and you can click on artist. And it's also like has keyboard navigation and everything. And so the goal for this is to not overwhelm the user and give them like the few configurations that are most likely to use in practice. So now going back to the sloppiness, the last area I want to touch on is for if you're trying to draw circles, you're going to see like at the edge of the circle there's this little thing that comes out, and this like makes it gives in like some of the like handwritten feeling. And so the way we are drawing this with Excalidraw and Rough, the library underneath that we're using, is first you need to split the circle into like a handful of points. And so, and now you do like basic curve between those. But now the trick for this one is instead of linking the last one to the first one, you're going to link the last one to the second one. And so now this one's going to be linked this one, and this one's going to be linked to this one. And so it's going to give like this little effect that's there. And so again, like this is like a very simple trick, but in practice, it makes a big difference. So now that we've seen like the hand-drawn effects, and it actually like surprised me because at the beginning I was like, oh, this is like a side experiment like in January 1st. But the crazy thing is that it actually started taking off. And so like there was a huge buzz at the beginning and like a lot of people started using it. But then it didn't go back all the way to 0. And it actually, there's like, at this point, there was a few thousand people using it every single week, which is like insane, going from like 0 to a few thousand weekly active users in like just 2 months. But it proves that like the hand-drawn feeling and all of the UX thing that we've done actually works. But what nobody could expect is that the coronavirus like situation happened. Everybody started working from home, and Excalidraw started having a huge uptick in the usage. And so you can see this, and now it's stabilized at like around 12,000 weekly active, which is like mind-blowing to me. Like there was like basically a 5x increase in usage like basically overnight. And so now why is that? And so now that we are all stuck in our houses and we still need to be work and you still need to be able to exchange ideas. And so this is basically like a replacement. A lot of people have thought about it as a replacement for the physical whiteboard. And so what's very interesting to me is that I actually didn't start the project for being a replacement for a whiteboard. I started for like draw illustration for my blog posts. And in this case, but what happened is like, oh, now a lot of people started to look for like a virtual, like a replacement for the physical whiteboard. And they started, and Excalidraw was one of them. And a lot of people started to compare like Excalidraw with like a bunch of other solutions that are like labeling themselves as like virtual whiteboards. And now I was in a position where like I had to basically investigate, because people are asking me, oh, why should you use Excalidraw compared to the other thing? And I was like, I don't know, I've never heard about this tool, but I'm going to look into it. And one thing I found for this is that a lot of the other like competing products in this space were basically reproducing like the physical constraint of a physical whiteboard one-to-one. And it actually does, in my opinion, doesn't make a lot of sense in many cases. So let me go through a few examples. So the first one is trying to draw, to write some text. And so this is me trying to write whiteboard using my trackpad on my MacBook. And like this is very difficult, and the end result like look pretty terrible. And so one might say that like, oh, it actually looks like a 6-year-old like writing, but I do have a 6-year-old daughter, and like she writes way better than this. So this is not a good experience. But what's interesting is like if you're thinking about like the virtual, like you have a laptop, you have a physical keyboard, and like why not make use of it? And so for Excalidraw, we are able to just use the keyboard, and you're able to write it. And now the only twist that we have is we use a font that looks handwritten. And so funny story about this font. So this font was created by Elinor Rapp 18 years ago. Like 18 years ago, like it's a long time. And as Excalidraw started being more popular, like people that speak like Russian or Greek or Portuguese, they started asking a question around like, oh, why are the characters I'm using not actually written with this hand-drawn like feeling? And so this was because the font didn't support it. It only support like normal Latin characters. And so I dug up like Elinor's email, like, and I called emailer like 18 years ago. And the most wonderful thing happened. Like, she actually replied, and then she was super excited. Like, she told me like she's a font geek, and she added like 1,000 more glyphs to the font like 18 years later. And so now we have like a bunch of the like common languages covered using this font. And so I'm like super excited, and like this is also like some of the reason why I like open source so much, and like the React community around, is because now we're able to get to work with a bunch of random people that have never met each other or like know each other in the past, and like all work toward a common goal. And so this is super exciting to me. So going back to the whiteboard example, like another thing that usually happens for start drawing something, and then at some point, like you're going to run out of space because like this is a fixed whiteboard, and then you're going to make those like super long arrow and start drawing somewhere else. And so it makes sense in a physical whiteboard because like you cannot like make the room bigger, like those kind of things. But in a virtual world, like why do we need this? And so for Excalidraw, what you can do is you can start drawing it, and then we also do some nice things where you can start like copy and pasting things by alt drag. But then what you can do is just start scrolling. Like, wow, like 21st century, like you can start scrolling. And now you can start moving around the scene, and you're not limited by the physical limitation, or you can start moving things, or like selecting and moving things around like super easily. So those are like the things, and I think this is something to think about. I've seen this pattern where like when you want to emulate like a physical product to the digital world, like the first version of all of those is you're going to like just port one-to-one and like not realize like the limitations actually don't make sense, and that there's other ways you can do things. And so think about it when you're like building your products, and see, because there's likely going to be a physical equivalent, and see like what are the things that, what are the parallels. And so in this case, I'm not sure if you can see it clearly in this, but all of the three circles are actually look different. Like there are different randomness. And so the way we get it is rough.js, the library underneath that gives us like this rough hand written feeling, is actually giving us every single time a different like looking circle. And so this is like very good when you want to like do one-shot rendering. But in this case, like Excalidraw is a React app, and the way it works is every time we like update something, we do a re-render. And so using this naive version, like, oh, every time you scroll, every time you move around, every time you're going to get like a different looking circle, which is not what you want. What you really want is for this circle, I always want it to be that shape. And so using in basically like the concept of a seed, where like all of the randomness starts with this number and is always the same, like no matter how many times you compute it. And so unfortunately, rough.js didn't give us this capability. Like it didn't have it. And so I started looking into the code, and like the way it works is like, oh, rough.js, the circle, it calls mass.random. And then it calls it like a bunch of times. And I was like, how can I? Yeah, actually we're in JavaScript. So actually I can I can modify math.random with my custom function to return like whatever numbers I want. And so this was like one of the realizations where like, oh, I can actually like modify rough.js behavior without even having to change the code. And so now that we can actually do that, so how are we going to make it work in practice? So the first thing we need to do is to have a random generator that actually accepts a seed. And so now, as any good engineer is going to do, you Google for it, you end up in Stack Overflow, you scroll through it, and then you see like a one-liner that's like, oh, this is like super cool. This is a one-liner math random number generator. So in practice, this is a terrible random number generator. Like, please don't use it. But it fits in the slide and looks cool. So I decided like, oh, let's go for it. And so now that we have this random number generator, now how do we wire all of this together? So what we want is to have this function with seed. So you said like, oh, I want this seed, and then call an arbitrary function, like in this case, rough.j.circle, and it's going to update math.random to like start with this seed. And so the way it works in practice is you're going to save a copy of math.random so you don't lose it and you don't clubber the namespace. Then you're going to update it with your custom function, and then you're going to call the callback. And once the callback returns, you get the results, and then you're going to put back the old math.random into place, and you're going to return the result. And so this is like a very powerful technique that fortunately we don't have to use that much those days, but it was very useful like in the early days of JavaScript. And fun side story, this is like how the technique we used in the beginning of World of Warcraft to be able to like split one monolith add-on into a lot of different add-ons. And now Blizzard provided like a facility to be able to do that by default. So it's been really nice. So this is like some of the interesting JavaScript tricks we've been using. But in this case, the good thing is the person that built rough.js like added the seed option built in. And so now we don't need to do any of those kind of crazy things anymore. So now the next topic I want to talk about is end-to-end encryption. And so one of the things with drawings like this is you're basically putting in your mind, putting all of the drawings like from your mind, and there's a lot of sensitive things. And so we've worked through many examples of like mocks, people actually using it for interviews, or we've been involved in a reorg recently at work, and like, oh, people have drawn like the next organization and everything. And so those are like all kind of things that like you don't want to leak and you don't want to like go into the wrong hands. And so this is like something, especially working at Facebook, like privacy and this kind of thing are like super dear to my heart. And there's been this, and so WhatsApp actually like pioneered, like actually evangelized this way of like end-to-end encryption. And so I'm going to go through a bit of like how it's working. So first of all, where do we need end-to-end encryption within Excalidraw? So by default, like nothing is sent to the server, like no logs, like none of your SYN is sent to the server. And there's only two use cases where we actually do it. So the first one is when you want to share a link to a SYN. And so in this case, it's like a lot more convenient than actually like saving a file, sending to the person, asking the person to like load the file on excalidraw.com. Like this is a painful process. You can just send a link. And so in order to do that, we need to send the SYN to the server and hopefully end-to-end encrypt it so it doesn't leak. And the second part is the live collaboration. Now, if you want to do like interview setting or you want to collaborate on mocks or those kind of things when we're all working from home, we need like the server to be able to send like, oh, this person updated this and those kind of things. And so I'm going to talk to you about like how the server, like the end-to-end encryption works. So the first, taking a step back, like how is like the normal web working nowadays? So in the previous, like back in the days, like everything was unencrypted and like this was like basically the Wild West. But now everything is, or almost everything is using HTTPS. And so the way HTTPS works is like the client can sit in clear, and then you encrypt it, you send it to the network, and then the servers like decrypts it and like now start to seeing it in clear. And so in this case, this solves like a huge problem where like, oh, any router or node or proxy or whatever like in between like you and the server like could read everything, and now it's no longer the case. Now the main thing we have to worry about is the server being taken over. And so in this case, like, so we're doing like all of the normal procedure to like help with like the server not being compromised, but I like don't know like what's going to happen, and maybe it's going to get hacked in the future, like I don't know. But one thing I want is I don't want to be liable, and I don't want like all of your private scene that you've shared in URLs to actually leak and to like be on the hands of like people if that ever gets happens. And so what we really want is like, oh, the server not even being able to see the content. And so now we can actually do it. And so what we want to do is basically the client to start encrypting the content and send to the server. And now the server is basically an opaque encrypted blob that he has to store. And so now the big question is, now you send this to another client, how they can download from the server like the encrypted thing, but how do they decrypt it? And they need to get the key from somewhere, and from somewhere like the server actually cannot read it. And so for this, we're exploiting a feature of like the URL, which is that everything after the hash sign is actually not being sent to the server. Like this is only kept in the client. So now what you can do is, oh, hey server, like go there, like give me the scene like 1, 2, 3, 4, and then oh, I'm going to use this private key to be able to decrypt it on the client side. And so this is like the main trick to get like end-to-end communication working in the JavaScript, like in the front-end world. And so it's pretty like, nifty trick, and it works well. And so in order to do that, now we need like primitives for doing cryptographic operations. And one of the reason I had is that actually the browser now, and there's a crypto API that's supported by like all of the browsers, and it's working like super well. And so you basically can generate the key, you can encrypt the content, and then you can export the key. And one of the things for this is like super verbose and like not very intuitive. And the reason for this is like, oh, there's like a lot of parameters you need to do, and you need to like work with binary data instead of textual data. But the fantastic thing is it actually works. And so this is for the encryption, and for the decryption, like this is the same. You can like start importing the key and start decrypting it. And so now I would highly recommend like when you're building like your next app or next like product, like think about like, does the server like really need to know about this data? Can you try to do without? And in many cases it's possible, and it's going to like at least for me it's like a comfort of mine, and I can widely share Excalidraw, and I know that like it's not like all of the drawings, like even if we get compromised, are not going to be like out in the wild. So I sleep much better at night. And the last part I want to chat about is about like rendering. So how do we actually render things? And so actually, like I don't know if you noticed, but I spent a lot of time like trying to find like good stock images for this talk. So I had a lot of fun doing that. So the big question is, we have this circle, like how does it actually work in practice? So the first step that we have within Excalidraw is we keep like a JSON around all of the fields, like all of the attributes of this circle. So in this case, like, oh, this is the height and the width, and this is like an ellipse, and the position, and the stroke width, the stroke color, the C dimensions. And so you get all of this description of the elements in the scene. And so unfortunately, Recall was not open sourced by the time I started working on Excalidraw, but I would definitely want, like if I were to do it again, want to use Recall for this, because it's like the perfect use case. And I would be pretty open to like seeing if we can use Recall now in the state that it is in. But yeah, we couldn't use it. So now that we have this description of like, oh, there should be a circle with this kind of shape and the seed. Now, how do we actually like get this like hand-looking feeling? So we call rough.js, and then it gives us a list of operations. And so as I mentioned earlier, you got like a bunch of basic curves, like probably like, oh, there's a basic curve from this, and like all of those basic curves. And this is basically a lot of sequences of basic curve. And now, so we know like what are the paths that we need. And so now we need to actually render them, like draw them. And so there's two options for this. So the first one is to use Canvas. And so for Canvas, there's a nifty thing, which is like Bezier curve 2. And so now I can draw like all of these Bezier curves, like can send these commands to the Canvas and going to happily draw them. And you can also use SVG, where like SVG also like supports like paths like this. And we actually use SVG for, we can export like both to PNG or like JPEG or to SVG, which is like handy. And so now the rendering sequence basically looks like this. It looks like, oh, you've got the description tree, and then you got like all of the operation for every shape, and then you've got a canvas operation to actually draw it on the screen. And so when we started doing the project, we basically did this on every single update of the state. And every time you scroll, every time you move something, you selected something, like we did this. And so it was actually like surprisingly like not slow. So now the browser are like pretty fast at those kind of things. But for like as the scene grew bigger, like it started slowing down. And so now the main way, like the main efficiency for this is to start adding a caching layer. And so for this, we basically want like, oh, if the description didn't change, like the operation didn't change and the canvas didn't change. And so we are able to like cache this and cache this. And now one of the interesting things is like, let's say you actually cache the canvas and the pixels. Where do you cache it to? Because you cannot cache it like on the rendered scene. And so now what we do is for every single element, we store basically the image is going to be rendered. And then we use the context draw image canvas, which is basically just copy and pasting the content of the buffer into the final image. And one of the things that we realized is, and I knew already, but like copy and pasting like memory is the fastest operation that like a computer can do these days. And so this turned out to be like a huge performance win. And so we use the Chrome DevTools in order to like start optimizing. And so before the canvas caching, it took like 30 milliseconds for like a not so big scene. And so it means like on every single drawing or move on everything, we will do that. And now it takes like 3 milliseconds when we just copy paste stuff. And so this is what allowed us to have like the smooth scrolling even in like a very large scene. Now one of the challenge with this is the first time you actually load it, you still have to like generate this for the first time. And like this is now where like most of the bottleneck is. And so we have a bunch of ideas around how to like optimize it or like make it like sequential, like, oh, request animation frame, you only do like some at a time. But this is like for future improvements. So this is like all of the content I have. So unfortunately, I have only so much time. So, but there's a bunch more things if you want to look at our blog, blog.excalidraw.com. Like we are posting a bunch of like technical insight around this. And one thing I want to end with is like, thank you everyone like involved, like all of the contributors, but all of the users, all of your like tweets and everything. Like it's super heartwarming that we built something that is actually useful for people. And please like be safe in this time where like there's a coronavirus, everybody's working from home, like with kids, like with elders, like with people sick. Like please be safe, and thank you very much.
So, Christopher, this is very mind-blowing. And I think of current existing tools like GraphViz, React GraphViz, GraphJS. I'm trying to think of how I would use this. So, is the idea for a user, from a user's perspective, to make this something, and sorry for bringing up other product names, but something like Lucid Charts or something like that, but with a more of a hand-drawn perspective. And I also wanted to ask you if you ever heard of something like Git GraphJS, which is a way by creating React code and components to, for instance, map out a Git branching strategy or something like that. Could you see it being used for things like this? Is it meant to be used for things like this? UML diagrams, stuff like that?
Yeah. So my goal with this is to be able to like manually, like as a human, to be able to draw those kind of things. And so this is like my intention. And one thing I found is that a lot of those like things like automatically export things are good for like general things that we do have a lot of context. But if you want to like convey something, then one thing I found is like nothing beats like custom drawn kind of thing.
Yes.
Especially for blog posts where like you want to like put only the things that are like important to convey the message, or like same for slides illustration. And so you want to have like full control of like everything where things are.
Yep.
Now that said, like people have started using Excalidraw in interesting ways. So the people have started reverse engineering like the file formats. And so it's basically a JSON file with like a bunch of shapes, as I mentioned. And they started like taking all of the outputs that's like chart generators or like the Git tree are,
Yep.
and like output like Excalidraw files. And so now like, you can load it in Excalidraw and like it actually looks handwritten. And so this is like totally possible, and it's like a pretty nice hack. And one thing I want to do in order to like make this process smoother is to have like a Node API that basically does the Excalidraw to SVG or like to PNG generation. And so now we haven't quite done this. Like we need some like more plumbing, but this is totally possible. And if someone is interested in contributing, I would be welcome. But yeah.
So we had a question in the chat. Is there a way to group shapes and resize them together?
So resize them together. So Daishi has been working a lot on this. And this morning he's just landed the ability to resize groups that contain lines. Before it was not possible. And so now we are able to. For grouping, we are looking for like help around the pull request. So this is like a feature that we wanted, and unfortunately like we didn't nobody at the time or like was interested enough to like finish an implementation. And one thing I think for groups is like one of the use cases I see a lot for groups is you've got a text within a rectangle. And
Yep.
so we are already able to like detect when you're double clicking in the middle of a rectangle and say like, you're going to like actually put in the middle. And so what I want is to introduce the concept of layout dependencies, where now if we know you created a text within a middle of a rectangle, then we put a dependency between the text and the rectangle. And so now if you move the rectangle, it's going to also move the text. And same for arrows. If you create an arrow to a shape or like next to a shape, then if you move the shape, it's going to move the end point of the arrow with that shape. And so this is something I've been wanted. We have I created an issue about it called layout dependencies. But again, like we haven't had the time or like nobody else like contributed. And so this would be like a really nice addition to Excalidraw.
So yeah, I can also I can think of some other additions like being able to shade and fill, maybe fill a shape with a hatched shading, or kind of like the scribbled line drawn shadings, but still be able to add text and for it to stand out beyond it. So I'm sure that you guys have already thought of a lot of these things. And
and so now the interesting thing is the trade-off between like all of those features and how do you make them simple. And so, for example, like one of the things we want is like to add as few possible like shapes and like start combining them in interesting ways. And so, for example, for the arrows, like you may want like just a straight arrow, but you may also want to have like an arrow with like a bunch of points. And so now we've been able, if you click and drag, now it creates a straight arrow. But now if you click and then click and then click and then click, now you can like have multiple points. And now we had the same thing for lines. And now if you actually like the last click is actually like a point in the shape, then you can actually like have a background for this. And so trying to like combine as many possible, like think about like as many options, as few options as possible, like combine in like interesting ways in order to do things. So.
Right.
Have you thought about allowing people to share shapes, or like for mocking UI, sharing buttons, sharing?
This is something like is a common source of like questions. So I think for this right now, I don't have a good idea of like what would a good model for this look like. And so I think we need to have like some more, some people that are thinking about like what is a good design for this that would fit in Excalidraw. And then once we agree on one, then we can start implementing it. And I don't think the implementation is going to be tricky. Now there's a lot of considerations for this, like, where does this live? Can you get it from like the internet? Like, now do you have to have a website to share all of those? Or do you store them locally? Or all of those kind of considerations. that like need to be thought about.
Yeah, we had someone ask, what about using WebGL? He didn't expand much on that question, but
yeah. So this is actually something, yeah, for the rendering. Right now we're using Canvas, and the good thing about Canvas is that most of it is accelerated with the GPU nowadays with most browsers. And yeah, like one of the things that we could use WebGL for is we send all of the drawing operations to the GPU, and then we start drawing things in the GPU, and have a GPU cache to actually like start moving all of the things around. Now I believe that doing it in Canvas operation on like hardware accelerated Canvas is achieving the same effect, but I'm not 100% sure. So
Okay.
would love for someone to try it out.
Tavo asks, or actually Tavo says he has been using Excalidraw these days. So thank you for the contribution. Will Excalidraw introduce rotations of objects at some point?
Yeah, we already have a rotation. Yeah, we've introduced it like I think a month ago. So Daichi that I talked about. So there's a little like dots that you can click and move like shapes around, like rotate shapes around.
Do they have ways of like combining key combinations to constrict or keep the aspect ratio the same? Maybe even keep things on the same or line aligned in like a vertical or horizontal positions.
Yeah, for the aspect ratio, you can press shift and like it should respect the aspect ratio. I think right now it's not working totally in like all cases, but we're working on this. For the alignment, yeah, this is something like we want, but again, like nobody started working on this.
Sure.
And so yeah, this is one of the things with Excalidraw. What we're trying to do is to get like a lot of contributions from people. And so a lot, like the way I view myself as a project is basically like a PM around like what are the things that should be in or should not be, and like trying to figure out like to beta test like, oh, like this doesn't sound like well designed, or like there's bugs and everything. But I'm trying as much as possible, because like I don't have a lot of time myself, to get other people to contribute.
Yep. And I can see how some of the existing applications out there, like to draw UML diagrams or to draw network graphs and these types of things, they work well, but you have to the user interface is a certain way to where you have certain objects you can pull onto the stage, and sometimes it doesn't give you the ability to maybe just write in what you want, or to easily draw the lines like you said. And so I could see how something this could be very valuable and give you something that these other applications don't. That kind of custom or maybe just getting straight to the point, right? Sometimes these programs, you have to follow the way that they do things, and you can't just get right to the point and say, look, I just want to draw a line here between these two boxes. So yeah, very cool. And one more, would it be possible to add cloud storage for the export import?
So we already have cloud storage like with the link sharing. So it's already stored in our cloud and like end-to-end encrypted. Now I think what the person is asking is like more like a team thing, like Figma or like Notion, where you can like start listing like what are all of the things for all of the users. And so this is something that I want at some point. Now, one of the challenges, a lot of people have been asking, hey, how can you turn Excalidraw into a startup? And like, can you start making money out of this? And I'm like, I don't know, like I like my job at Facebook, and I'd like for it to be free. But yeah, and so a big the main business model I can see for Excalidraw would be to have like some kind of like team setup where like, oh, now like a business can pay like whatever amount per user, like Slack, and now they can like start using Excalidraw. And a lot of people are interested in doing those kind of things. What I would love is to be able to have something like this, but being free. And so if people are interested in like building something without the intention of like making money out of it, like I would love and I would cherish it. Now I understand like this is a pretty big commitment. The other issue with this is around like the end-to-end encryption. Because the way right now the end-to-end encryption works is like the server doesn't know anything. And now if you want to start having the ability to like, let people list like all of the scenes and everything. Now you need to have like some probably like centralized like storage management, and the server can start knowing what are all of the drawings and like the content and those kind of things. So there are like some pretty advanced crypto schemes to be able to like have the server not know. But then this is like a question of like, should we invest in all of that complexity, or should we just buy the bullet and like, yeah, if you're in the Teams work setting, then you're going to like the server is going to know about things. And now I've been involved in like the validation about the getting companies to use Excalidraw, and now they ask you like to fill like a 100-question questionnaire around like, what is your privacy policy, how do you train your employees, and like all of them are geared toward like more like companies. And so this is an interesting, how do you get this and all of the certification that like make sure like companies can use it without being a company, with just being an open source project. So I haven't still yet cracked this, but yeah, it poses interesting challenges. But to your original question, yeah, I think it's a valid use case. I think it would be like extremely successful and useful. And so if people are interested in contributing, like please let me know, and I can work on something together.
Seems like it'd be a great tool for tech interviews. Someone asked, do you know if any companies are using it in this way, or are you guys using it in this way?
Yeah. So at Facebook, we are like beta testing it, and hopefully within the next couple of weeks, months, we're going to like switch it over. HackerRank actually this morning just launched a product, a live interview product using Excalidraw in order to be able to like have the live collaboration. And yeah, I think this, and I've heard like a bunch of like smaller startups that have been using it for their technical interviews. And so this is actually why we built a live collaboration feature in the first place, is for this specific use case. So yes, this can be used. Yes, this has been used in practice, and has been successful.
You just took my last question out of my mouth and answered it. What are you guys using under the hood to do the live collaboration?
So right now for the live collaboration, this is something I wanted to touch on like during the presentation, but I didn't have enough time. And so we are just like, right now there's just like one Heroku instance sitting somewhere like I don't know where, and that's basically just a message broker. So it's basically like using Socket.io. So you create a room.
That's what I figured.
And then what it does is basically like, oh, anytime someone sends a message to the room, it just broadcasts it to all of the other parties. And now what we're doing is we have a conflict resolution algorithm that lets you take all of the updates from like all of those things, make sure like they are properly synchronized, and all of the parties like have the same states. And so we released the blog post about this on the Excalidraw blog, if you're interested in like how the technical details are actually working.
Yeah, Tavo is now posting images from Excalidraw in the chat. So very interesting to see what it can do.
Boom.
Great. I think that exhausts our question, and thank you very much. This is one of the most interesting things that I've seen in a while.
Thank you, Christopher.
Thank you very much. Have a good day.
Bye.
Cheers.
Bye.